Okay, so when we find a quotient, when we divide by a fraction, what do we always do instead? Multiply by the reciprocal. Okay, good. So then let's start with problem 2 here. The domain of this function is what? So we want to find all of the excluded values, right? Let's put all the phones away, please. We want to find all the excluded values. So here's my question to you. Does that mean that I'm going to divide by this second fraction, right? So that means it's going to get flipped. Does that mean that I have to find the zeros of the denominator before I flip it, or the zeros of the denominator after I flip it, or both? So if I were to write this as just one big quotient, it would look like on top I've got x squared minus 4x minus 5 over negative 5x, and on the bottom I've got this guy, right? What do you think? Good question. Because I'm gonna divide by that bottom one anyway. Doesn't it kind of just seem like I shouldn't have to worry about the zeros of this denominator being as I'm gonna flip it? The answer is I do. I have to work about. Here's kind of the way you can define this. Any part of a rational function that is going to be in the denominator ever while we're solving this thing, those are values of x that have to be excluded, because you can never divide by 0, right? This quotient wouldn't make any sense if I were dividing by something that was undefined. That doesn't work, right? See what I'm saying? So I mean, like, let's go ahead and factor these real quick. So what do we get when we factor the numerator of the top rational expression? What do we get there? X minus 5, x plus 1 divided by negative 5x. Okay, so there's our numerator. And then how about these two? What about the numerator of the denominator, so to speak? What do we get there? X minus 9, x plus 1 divided by, and on the bottom, what's that factor into? What do I do there? One more, almost. 4x. So I can take out a 4x, leaving me with x plus 2. Okay, so at that point right there, if I were to, we have to have what excluded x values? Yeah, we have to have 0 for a couple reasons, right? Because, first of all, I mean, if we look in the numerator, for this rational function to be defined, I can't have x equals 0, right? Or I would end up with infinity in the top, which I can't have. Same thing in the bottom. And then I've also got a negative 2, a value of negative 2 that also would make this bottom rational function undefined. It would make it explode, right? You can't divide by 0, you can't divide by infinity. So we've got to start a list. So what are the values we have to exclude? Well, it can't equal 0, and it can't equal negative 2. Okay, algebraically, you already told me the next step is to flip and multiply, right? So we end up then with so I'll multiply by the reciprocal of the bottom. Okay, and before we do any canceling, I've got to look at that and say, okay, now I've rewritten this by taking a reciprocal, and so now I've got potentially some other values of x I have to exclude. What other values do we have to take into account now? Yeah, this one's already taken care of, but now I've got the 9 and negative 1 that have to get added to the list. right? Okay, so now we've taken care of problem number 2, right? Now what?
Cancel.
We can cancel like factors, can't we? Because we're multiplying. Now, if we were adding, we couldn't do this, right? But when we're multiplying, we can always cross-cancel. So those guys go away. It looks like I've got an x plus 1 factor that goes away. And we end up with the result. I've got a negative on the bottom. Let's go ahead and just pull that negative out front. And then I just get x minus 5 times x plus 2 over 5 times x minus 9.
What happens to the 4 on the side?
Oh, the 4's there too. Whoops, I forgot that. So there's a 4 up there too. Yep. Okay. And then notice in the answer it wants you to write this as a rational function in standard form, where p of x and q of x are expanded out. So my last step would just be to do what? Yeah, multiply the whole thing out, right? Expand the top, expand the bottom, and we'd be done. Okay, does that make sense? So the moral of the story, the only part there that, that's I assumed would be a little bit strange and maybe problematic was dealing with this, all these extraneous terms you get when you do a quotient, right? Because you have to take into account all of the different permutations of the algebra. Every expression, every zero of the denominator, all the way through has to be excluded. Okay, one more. How about this? So this takes us up to 9.3. 9.3 for you guys is going to be easy. It's really, let's think about this in terms of what we already know about solving equations involving fractions. What would you do if I gave you a problem like this? Thinking back, we talked about this earlier in the year. You guys seem good at this. So what if we had something like x over 3 minus 2/5 equals 3x over 8. Thanks. Let me make this, just so we don't have such huge numbers, I'll make this guy a 4. What would you do if you were going to solve that equation? What's the first thing you would do? You'd clear all the fractions, wouldn't you? Okay, what would you multiply both sides by to clear the fractions? 40, yeah. How come? Okay, because 5 times 4 is 20, and that would go into it. 5 times 8 is 40. Smallest. What would I call that number 40? A couple different names that would describe it.
Least common denominator.
Okay, the least common denominator. If I were just going to add these terms up without clearing fractions, that would be the least common denominator. What is a least common denominator?
Smallest common denominator.
It's okay, but so if we look at all the numbers in the denominators, the 4, 5, and 8, do you remember what we'd call that number? Say it again. Yeah, it'd be the least common multiple, right? The smallest common multiple of all the denominators. But it's fine, that's what a common denominator is, what a least common denominator is. So we're going to just do the same thing, aren't we? We're going to multiply when we deal with something like this, where it looks a little more complicated because now we've got rational expressions where we've got x's on the top and the bottom. It's the same idea, isn't it? What is the least common multiple of all of the denominators, aka the least common denominator? Let's make a list of all the factors in the denominator. What if I factor this first one right here? We're just looking at denominators. We don't really care about the numerators right now, right? So if I take this first term, I get x squared minus 47 on the top. What's going to be on the bottom? What does that factor into? What numbers multiply 42 and add to negative 13?
76.
Okay, so x minus 7, x minus 6. And then here I've got my x minus 7. There I've got my x minus 6. Well, now what's the least common multiple of all the denominators? What's the smallest product I can make that includes, there's only two different factors on the bottom, aren't there? So what is it? Well, it's x minus 7 times x minus 6. I mean, I could write it like that, but that doesn't really make sense. It'd be better to write it in factored form, wouldn't it? Right? So I'm just going to multiply both sides through by x minus 7 times x minus 6. Okay, before we go any further though, what are the excluded values for part 1? 7 and 6, yeah. So x, in this case, they just want just the values, so 7 and 6. If I multiply through then, so I end up with what's going to happen here? If I just distribute that through both sides, we get a lot of cancellation, don't we? Right? Over here, the whole thing cancels. So all we're left with is just an x, supposed to be an x squared. X squared minus 47, it's all that's left in the top. What about here? Well, I'm going to cancel those two, right? And I'm left with an x minus 6. And then here I'm left with an x minus 7 multiplying through on the top. And now we end up getting an equation that we can solve, right? So what's this give us? Here I've just got x squared minus 47 when all the dust settles. Here if I distribute the 2 through, I get 2x minus 12, and then here I'm going to get, what, 4x if I distribute minus 28. So I've got a new equation, but look at the advantage. Now it doesn't look like, the ratios are gone, right? Now this is just a simple quadratic equation that we've got to solve, and we've done about 1 billion of those, right? How do we solve a quadratic equation? No, without plugging it into a graphing calculator. Move everything to one side, so we got to put it in standard form, set it equal to 0. So let's push everything to the side where x squared is positive, right? So what's that going to give us? If I put all the x's, I've got 6x on this side, so I'll subtract those to the left. So they're over here now, and then I've got a negative 47. On this side, I've got, what's that, negative 40. So if I add that over to this side, I'm going to be left with a negative 7. Okay, check me, is that right? Does that work? Okay, so then what's this factor into? Let's solve this by factoring. X plus 1, right? Okay, so what do we get for our zeros then? Okay, are those both good? What's wrong? X cannot equal 7, right? 7 isn't, so we happened this time when we cleared the fractions and we solved, we got a solution that was one of our excluded values. So what do you think we would call that solution? It's a non-solution. What's our fancy math word for a solution that's incorrect? Yeah, it's an extraneous solution, right? So it's extraneous because, just so it's on the notes here, because there it is, right? Okay, so what's the only one we get to keep? Negative 1. Okay, so in Moodle we would just input that. Okay, does that make sense? I don't think I'm gonna say any more about that for now. I think I'm just gonna let you work. Go. If you have questions, by all means, come on up.